This video will show how to run external scripts through the command line in ShapeBuilder. Let's get started. In addition to using the command line directly as shown in previous videos, more complex scripts can be generated in any text file and read into the program. This allows parametric studies to be performed, finite element meshes to be automatically refined, CAD files to be batch processed, and much more. Note, when developing external scripts to be ran in ShapeBuilder, any C# code can be used along with the commands that are already built into the program. The help file contains a number of example scripts to help us get started running external scripts. Let's launch the help file and navigate to the external scripts page. We will start out by looking at the process CAD example script. This script was developed as a response to the numerous requests to add a CAD batch processing feature to the program. This feature will provide great time savings when processing multiple CAD files. The process CAD example script starts out by setting the units in ShapeBuilder. Next, it defines the folder where the CAD files are located and also defines the folder where the results are to be saved. We'll need to update these paths on our specific machine before running the script. Next, the script defines the material for the imported shapes. Right now, the script will launch the material database so we can choose the material, but we could hard-code the material into the script if needed. Now, for each CAD file in the folder, the script imports the file, waits for the simple analysis to complete, zeroes the centroid, generates the dimensions, and zooms to the extents of the cross-section. Next, the script sets the mesh and waits for the advanced analysis to complete. Note, this part of the script is only required if we want the advanced torsion shape properties. Also, we could add a loop to the script here to refine the mesh automatically if needed. After this, the script adds the sketch view and several tables to the report. Next, the ShapeBuilder file is saved, a PDF of the report is saved, and the section properties are added to the section properties table. Finally, the project is cleared before importing the next CAD file to be processed. Now let's copy the code to the clipboard and paste it into a text file. We'll then update the paths to the toProcessed folder containing the CAD files and to the processed folder for the results, and then we'll save the text file. Before running the script, we see that the toProcessed folder contains 5 CAD files with drawings of various steel sections, and the processed folder is empty. Now we can type browse into the command line, navigate to the script file, and open it. As expected, the first thing we see is the material database open for us to choose the material to use for the imported shapes. Next, we see the various shapes get imported from the CAD files, and we notice that the centroid is zeroed, the dimensions are generated, and the window is zoomed to the extents for each shape. Upon completion, the command line informs us that 5 CAD files have been processed. Opening the process folder, we see that 5 ShapeBuilder files have been generated, 1 for each CAD file, along with 5 PDF reports. Furthermore, we see that 1 text file that contains the section properties for each shape has been generated. We can easily open this text file in Excel to see the spreadsheet of the section properties for the 5 shapes. Processing these CAD files via the user interface would have been tedious and much more time-consuming than the few seconds it took us to process the CAD files with the external script. Also, keep in mind that this script can be modified to function exactly as needed for each particular situation. Next, let's look at the refine mesh example. This script automatically refines the mesh until a defined property converges. For this case, we will look at the torsion constant J, and the refinement will stop when the change in the torsion constant is less than 1% of the previous value. Note, inside the while loop in this script, the await advanced analysis command is used to pause the script until the analysis completes so that the section property for the shape can be obtained to compare with the value from the previous iteration. Having already saved the script in a text file, let's load it into the program by entering the path in the command line. As the external script runs, we see that the mesh of the shape gets successively finer as the script iterates towards the converged solution. Finally, we see that J converges to 40.69, which is 0.51% change from the value in the previous iteration. One advantage of using scripts is that you can easily change the parameters in the script, save it, and read the script back into the program. Finally, let's look at the optimize angle example script. This external script finds the thinnest 4" by 4" angle that can handle an 8 kip shear force. Since the force is applied at the centroid, the shear stresses are a combination of both flexural shear and torsional shear. Notice that this script contains two while loops, one to incrementally increase the thickness of the angle, and another to ensure that the resultant shear stress has converged since it depends on the finite element mesh density. Having already saved the script in a text file, let's load it into the program by entering the path into the command line. As the script runs, we see the thickness of the angle progressively increases. Also, we see that the mesh is refined for each angle thickness. Finally, the script reports that a thickness of 0.563 inches is required and that the extreme stress is 16.29 ksi, which is below the allowable stress of 19.44 ksi. In just a few minutes, we have used the command line to run external scripts to batch process CAD files, refine the mesh for a cross-section until a specific section property converges, and to optimize the size of an angle to resist a given load. These examples just scratch the surface of what can be done with external scripts in ShapeBuilder. We hope you find this new powerful feature useful, and it saves you time and increases your productivity in the program. Thanks for watching and have a great day.